everybody. Let's do solutions to problem set 3. All right, so this one's about methods. I have a problem where it's sort of like nonsense code, but there's a couple of methods. There's isFlorid, there's makeVals, and there's expand, and there's score. And so we're going to declare these methods, and the whole trick is the method signature, which is that first line of the method, has to take the right kind of input and give the right kind of output. So let's do it. Okay, so here I am. I've typed the code. Let's do isFlorid first. So what I'm noticing about isFlorid, well, let's type out sort of a generic template. So I'll say public static. You don't know what static is about yet, but we'll get there. And then there's the return type. There's the variable. There's the method name isFlorid. And then there's the parameter list, which is the comma-separated list of variables that are going to hold the input values. Okay, so what is flopbot? Flopbot I see as a string, so that means isFlorid needs to accept one string as input. So here I will type string, and I'm just going to call it A. It does not have to have the same variable name as the variable that's supplying the value. So when I run the method, when I call the method, flopbot immediately is replaced by its own value, fox and socks. So this variable here, its only purpose is to give a value that gets passed inside of this variable. And so this one I can call whatever I want. Okay, well, so we don't know what actually happens in the inside, because that's not what this problem's about. What has to be the return type here? Well, I can see that whatever isFlorid returns, whatever its output is inside an if statement. And I know that an if statement only makes sense if whatever is inside the parentheses eventually evaluates to be true or false. So that means that this has to return a value that's true or false, and the data type for that is Boolean. So the first method should be public static Boolean isFlorid string whatever. Okay, let's do makeVals. So makeVals, I noticed, so let's do the generic template again, public static something, makeVals something. All right, what's the input? The input is n. I look up here and I notice that n is an integer. So I'll have a variable here that's an integer. I'm going to call this one n also. Okay, what about the output? Well, I know the output is going to get assigned, because it's on the right-hand side of an equal sign here, it's going to get assigned to this data type. So what that means is that makeVals must be returning an array list of integer. So here I'll say array list integer. And so that's the correct answer for makeVals. Let's do score. So public static something score something. All right, so score takes vals as an input, and vals was this array list of integer. So the input parameter here is going to be an array list of integer, and I'm going to name it list. Okay, what is going to be the output from score? Well, I see the output from score is going to get assigned to the variable s, so that means score has to output a double. Okay, last one. Expand. Public static something, expand something. All right, so expand takes, it looks like 3 separate input values. It takes vals and then s and then Dr. Octopus. Vals was the array list integer. So here in expand, I'll have an array list of integer that I'll call list. S is a double. So next I'll have a double, which I'll call num, or I'll call score. And then next, it takes this string, Dr. Octopus. So now I'll have string str. So what you're checking here is that expand, when it's run, has 3 input values of different data types. So when you define expand, you need to have 3 declared variables, 1, 2, 3, separated by commas, and the data type for each variable has to match the value that you're trying to give to it. Okay, so what does expand return? Expand is going to return an array list of string. I know that because it's whatever the return value is gets assigned to IDs, and that's the data type for IDs. So the return type will be array list string. Okay, that's that one. Let's do number 2. Okay, do this one off the computer, it says. Okay. Consider the method signatures below. Each call has something important wrong with it. What's wrong with each one? All right, so let's look at them. So method 1 3 high. So I'm giving it an int and a string, but if I look at method 1, it wants a string followed by an int, so the ordering is wrong. For B, I'm running method 3, but it says double 2.3, and you don't want the word double in here. You only have the word double if you're going to declare a new variable. So here in method 3, it says, the reason it says double C is because I'm declaring a completely new variable, which I need in order to hold the input number. But here, when I'm running the method, I'm not creating any new variables. I just want to give it the input number. So what would be correct here would be to just have the number 2.3 that would then get passed inside the variable C. Okay, what about method 2? Method 2, it looks like takes no input at all. But here I'm trying to give it an input that says high, and so that would be wrong. Method 4, I'm passing it true, true, false. So I'm passing it 3 Boolean variables, and method 4 does need 3 Boolean variables as input, so that's good. The output from method 4 is going to get saved into an integer, but here method 4 is outputting a double. So what that means is method 4 could output a number like 5.9, but you can't save 5.9 into an int. So that's the problem. E. So method 1 is a void method, which means that it doesn't have any return type at all. But if you're going to have the output of method 1 be inside a print statement, it needs to output something. It needs to return like a string or like an int or something. But the fact that it returns nothing means that there is nothing that println can print because there's no return value. Do the other things match? Yep, the other things match. Okay, so that's the problem with all those. Let's do some short ones. Run each of the methods from main to be sure they work. Okay, great. So write a method called max, which takes 3 ints as parameters and returns the largest of the 3. All right, it says run them from main, so let's do that. I'm going to delete all these. Okay, so I want max with like 3 different inputs. So again, I'm programming by intention. I'm assuming that max exists. I have a test case that I can use to see if it's doing the right thing. And now I'm going to make it. Ordinarily here, I would... it wants to import some maxes. Well, so ordinarily I would have it automatically create the method signature, but since that's what we're practicing, let's do it by hand. So we'll do public static. It's going to return, did I say ints or doubles? Ints. So it'll return an int, max, and then there will be 3 numbers that are the input. So that's the method signature. 3 inputs that are int, 1 output. So a nice way to do this, I mean, you could do this. You could say, like, if A is larger than B and A is larger than C, then return A. And then if B is larger than A and B is larger than C. This is like a little bit awkward, though, because what happens if like several of them are equal to each other? You know, maybe we could do this. You'd have to think through, does this actually make sense to do? And then here we'd say return C. So something like that could work, but I'd given a recommendation that you can use math.max. So you can't say math.max and give it 3 inputs. If you could, then we wouldn't be writing this method in the first place. But math.max will return the larger of 2 numbers. So I could do this. I could say, let's first figure out what's the larger between A and B, and then let's return the larger between that one and C. And even this is a little bit longer than it needs to be, because I could nest the calls. So I could say math.max. First, let's find math.max between A and B. And that will be, like, whatever this returns is now going to be the first input to math.max. And then I'll use C as the second one. And so that's like a nice clean one-line solution. Let's run it, make sure it works. It returns 6, which is correct. This is not a thorough test. You would want to test lots and lots of different situations. So here, the middle one was largest. You'd want to test if the first one, what if the first one was largest? What if the last one was largest? What if there's a tie in the largest? What if there's a tie in the largest, but everything is negative? So you'd want to think of a whole bunch of test cases. But we'll cover later in the year what would be good test cases. So that's still working. All right, let's do the next one. It says, write a method, throw, that takes no inputs, but will return the word rock, paper, or scissors, each with equal probability. All right. So if it takes no inputs, I run it with empty parentheses. Let's define the signature. Public static. I know I want it to return either the word rock or paper or scissors, so it'll return a string. You still need the open closing parentheses here, even though there's no inputs. What is it not like here? Public static string throw empty. I have told you to use a reserved word. Okay, so the fact that this is orange, see how public is orange and class is orange and static is orange? Those are all reserved words in Java. Throw has a specific meaning in Java, so we're not allowed to name our own method throw. However, I think we could probably name it with a capital T, which violates naming conventions. Usually you should not name your methods with a capital T. I wonder if you guys caught that mistake. Anyway, cool. So right now I just returned rock with 100% probability. How would we return something with equal probability? Well, one thing you could do would be this. So let's try and generate a random number between 0 and 2. And so now we can say if num equals 0, return rock, else if num equals 1, we'll return paper, else we'll return scissors. And I didn't even need to say if num equals 2, return scissors, because I know if it's not 0 and it's not 1, it has to be 2. And so I'll just return scissors. Okay, yeah, maybe that's enough. Let's just do that. Part C is in range. So I want to write a method is in range that takes 3 doubles as inputs and returns true if the middle value is between the first and the last. So here 1.0 is not between 1 and 2, but 1.01 is between 1 and 100. All right, I get it. So is in range. Let's run it with 1.01 and 10 like this. Let's write the method signature. So static. This is supposed to return true or false. And you can tell by how I named it. Is in range is sort of asking a question. Is it in the range? Yes or no? So it should return a Boolean. And I'm just going to have 3 doubles. All right. And what do I want to test? So you could do this. You could say if A is it supposed to be inclusive in the range? No, it's supposed to be strict. So if if B is larger than A, if the middle one is larger than the first one, and also the middle one is less than the last one, then return true, otherwise return false. So this will work. This is good. Notice though that, well, let's do this in 2 steps. So this expression here is going to evaluate to be either true or false. If the highlighted part is true, I return true. If the highlighted part is false, I return false. So in other words, I want to return whatever the highlighted portion evaluates to be. So I could do this. You might not have been aware that you could do this, but you can totally do this. I can define a variable, result, that gets assigned the true or false value that used to be inside the if statement, and then I'll just return the result. Because if this was true, result will be true, and I'll return true. If this is false, result gets false, and I return false. So this does the same thing. And now that we see that, it's maybe even a little bit superfluous to declare the variable results. Why not just have that straight in the return statement? So this would be kind of the shortest answer. Rather than say, if this is true, return true, otherwise return false, I can say, return whatever this evaluates to be. And that would be the same. All right, let's do the next one. So this says, write a method called getThrows that takes an int n as input. It should return a string of n random rock, paper, scissors throws separated by commas. If the input isn't at least 1, then return the empty string. Got it. All right, so getThrows, and then I give it a number, like 3. And let's declare the method. It's going to return a string. It's called getThrows, and it takes an int n as input. All right, so what do I want to do? Well, it said if let's do the failure condition first. So the failure condition was if the input isn't at least 1, then we should return the empty string. So let's just do that right away. If n is less than or equal to 0, then return empty string right away. And so now I can write the rest of my method, assuming that n is at least 1. All right, so if n is at least 1, what do I want to do? It says I want to have a bunch of hyphenated, separated by commas. Oh, I see. So rock, paper, scissors, like that, separated by commas. All right, so let's create an output string that starts as the empty string, but then I'm going to loop n times. So if n was 10, this is going to loop 10 times. If n was 3, this is going to loop 3 times. And what I want to do is I want to add to the end of output. So output equals output plus, and then here I want to have rock, paper, or scissors. So hopefully what you're thinking now is, aha, we already have this method throw that returns a random throw. So that's what I'm going to do. I'm going to run throw. It's going to return a string, and I'm going to add that string to the end of output. But I also want to add a comma there. And now I'm done, so I'll return output. This is going to be ever so slightly wrong, and let's run it and appreciate why, and then fix it. All right, so here it's displayed rock, scissors, scissors. Let's run it a couple times. Here it's displayed scissors, scissors, paper. Let's run it again. Here it's displayed scissors, paper, scissors. Let's run it again. Here it's displayed paper, paper, paper. All right, so that seems, sort of to be working. One thing I'm noticing, though, is we have this extra comma at the end that we don't want. Probably the best option for you. So in Java, if you have a string, there is a way of saying make a new string without the last character. So I could just kind of cut off the last character, but you don't know that part of Java yet. So let's do this. Instead, let's not loop n times. Let's loop n minus 1 times. So this is going to loop 1 fewer times than we want. And then at the end, let's just do this. At the end, we'll do output plus equals throw with no extra comma. So what we're doing is, as long as we're not on the last number, we'll generate the random throw and then a comma. And then this one represents the last throw we'd ever want to make, and there's no comma there. And so that ensures that we're not going to end with a comma. So let's run it again. Okay, so now we got paper, rock, rock. Paper, rock, paper. Okay, so that seems to be working. Cool. Let's do 4 methods that call other methods. So we've already done that. Write a method called countFactors, which takes 1 input and returns the number of unique factors for that number. Okay. Great. So up here, I'm going to comment all this out. You can highlight a region and do Control-Shift/, and that will comment the entire region. Control-Shift/. Let's do count factors 10. All right, so public static, this returns an int. It's called count factors. It takes an int as input. Okay, so counting factors. So I can use divisibility here. Remember that if I say like, so let's start count at 0, or let's start count at 1, because 1 is always a factor, because 1 divides everything. So I could say like if n mod 2 equals 0. So if n were divisible by 2, then let's add to the count. And then if n is divisible by 3, let's add to the count. And if n is divisible by 4, let's add to the count. So I'm testing each number one at a time to see if the remainder would be 0 when we divide by that number. Because if the remainder is 0 when we divide by 4, that means 4 is a factor. And so I add to the factor count. The problem here is, how high do we go, right? I can't just do this with if statements. So we need a for loop. Because we're doing the same thing over and over again. And when you find yourself doing that, that's a good indication that you need a for loop. So let's loop over the possible factors. We don't want to start with 0. And let's not start with 1 either. Let's start with 2. And we want to go up to and including the number n itself. Because let's say n was 10. If n is 10, then 10 is a factor of 10. It's not a proper factor. Did I say? Yeah, so I said we're not doing proper factors. It's all factors. Right, so I want to test 2 up through n. Factor count starts at 1 because 1 is already a factor. And so now I want to say if n, when you divide it by factors, yuck. So when you divide n by this, if the remainder is 0, that means we've found another factor. So we'll add to count. And then at the end, we'll return the count. All right, here I'm going to rename this because factors is plural, but this is just a single int, so factor, that's better. All right, so if n divisible by factor, then we'll add to the factor count. Cool. Am I missing anything? I don't know. Let's run it a few times. Okay, does 10 have 4 factors? Yes. 1, 2, 4, 10. Sorry, 1, 2, 5, 10. Yes. Let's do 7 and make sure 7 is prime, so it should have 2 factors, itself and 1. Great, and it says 2. All right, so now let's do is prime. A number is prime if it's only divisible by 1 in itself. Okay, so use your count factors method in your answer. All right, so let's do is prime 7. Let's define the method. Public static. This is asking a question. Is something prime? Yes or no? So its return type will be Boolean. And we'll take an int as input. We weren't thinking about edge cases here. I wonder what count factors does if we have a negative number. We haven't really been thinking about that. Well, let's not worry about that. But I am going to think about an edge case here. So if n is less than 1, we'll return false. Because 0 is not prime. 1 is prime, 2 is prime, but nothing smaller than 1 is prime. Okay, so what we can do here is we can say if, let's do this, num factors equals count factors n. So I'm taking the number I'm interested in. It's going to be the input to count factors, and so now I've counted the factors, and you can say if num factors equals 2, then we're prime, so we'll return true. Otherwise, we'll return false. Okay, let's make this shorter. So I don't actually need to store the number of factors because all I'm going to do with it is I'm just going to test it in the if statement. So I can already make it shorter this way. And then I don't need to say, if this thing is true, return true. If this thing is false, return false. Instead, just like one of the last problems, I could just directly return whatever this evaluates to be. So now I'm saying, if the number is too small, we'll return false. Otherwise, we'll return whether or not count factors equals 2. And so that seems like a nice short solution. All right, next one. I'm going to skip the fun way to test the method. It's like, okay, fun. It's, not that fun. Okay, so C, find prime larger than. So in this problem, find prime larger than some number. I'm going to start counting up until I find the next prime. And then I'll return whatever the next prime is. So let's do that. Int p, find prime larger than 99999. Okay. Let's declare the method public static. It's going to return an int. It is called find prime larger than, and it takes an int to start. If I give it a prime number as input, that it shouldn't return that same prime because it's called find prime larger than. So we should start our search one larger than this input. So I'm going to define a totally new integer called start, or no, num to test, which will be n plus 1. So I'm going to start my number to test at n plus 1, and I'm going to say while it's not prime, so I'm going to test whether num to test is prime, and if it's not prime, then I want to keep going. So as long as it's not prime, add, and then test it again, and then add, and then test it again. So eventually, the number to test is going to be prime, and then when it's prime, I will return the number that I wanted to test. Okay. So let me imagine what some students might have done. So you might have thought, okay, I want a loop. So let's loop starting at... So let's loop starting at n plus 1. But the problem is, and going up each time, but the problem is like we don't know how far we should go. And so here you could say if is prime I, then return I. Otherwise return -1 or something. Like we don't know, what if we never found a prime? So this is like kind of okay-ish. But the problem is like this is clumsy and awkward. Because we didn't know how large we should go. Technically speaking, you could do this. You could say integer.maxValue. So we could loop up to the largest thing that int could store. And that's, again, sort of okay. But I think conceptually it's a little bit better to say... Well, let's do it yet another way. I like the while loop a little bit better. So let's make to test equal 1, and then let's do this, while true. So true is always true. So this is just going to be an infinite loop. So I'm looping infinitely, and now I can say if to test, if is prime to test, then we'll return to test. Otherwise, we'll keep going. So to test plus plus. So this is now going to loop infinitely until we find a prime, adding to it. And I think, I used to say that this was bad style, but I think this is actually pretty common style, especially amongst like C programmers or like people who are programming in C-like languages. And then this one says unreachable statement, which means you can never get there. The reason we can never get there is because the while loop will never exit except by returning. So this is yet another solution that would also work. All right. That's the end. Okay. Pseudocode. Yes. Okay, cool. Hope that this was helpful.